In question 8 we're asked to find a point on the rod where a weight of 5 newtons could be placed so that equilibrium is just maintained. So I've already started to annotate the diagram. We've got reaction at P, reaction at Q from the two supports, and also the rod is a uniform rod of weight 6 newtons, so that acts through the centre point C. I'm going to put my 5 newton weight here on the point somewhere between A and P, and that's 5 newtons. And we know that this distance is given as x in the question as from C. For further information then, the distance from point P to the 5 newtons would be x minus 3. So the first thing to do would be perhaps to take moments around P, and we can see that the reaction at RQ would produce a anti-clockwise moment. The 6 newtons acting through the centre point would give us a clockwise moment, and the 5 newtons that we've placed there would give us anti-clockwise, and anti-clockwise moments should equal the clockwise for equilibrium to be maintained. So we have RQ times 6, force times distance, plus x minus 3 multiplied by 5 is equal to 3 times 6. So solving and expanding out, 6RQ plus 5x minus 15 is equal to 18. And we can see that slight rearrangement, 5x is equal to 33 plus 6RQ. Now, obviously we've got two unknowns here, x, which is the distance we require, and RQ. However, the greatest distance that the 5 newtons could be placed along AP in this example would be when the reaction at RQ is equal to 0, almost like a seesaw effect around P. As we move the 5 newtons close to A, the plank will eventually lift off Q and it would be out of equilibrium. So we're looking for when RQ is actually equal to 0. So we can use that in this equation. We can immediately see that 5x therefore becomes 33. Solving, x, which is the distance from C to the 5 newtons weight, is 6.6 centimeters.